Hello. Wait, what's happening here? Hello. Sorry, technical something. Hello. I will say hello more officially in a second. Good morning. Okay, wait, something weird is happening. Sorry, good morning. Okay, hang on. What is happening here? Oh, I think I get it. Okay. All right, let me start again. It's great to see you guys. Thank you. Hold on. All right, I'm going to start again. What's happening with the board? Okay. Good morning, Daniel. Hello, Ashley. Good morning, Zitlali. Good, thank you, Ashley. How are you? Okay, wait. Sorry. Good, thank you. How are you? You can't really answer. Well, I guess you could, but good morning, David. Good morning, Alyssa. Good morning, Michelle. Good morning, Molly. Good morning, Nikaya. Good morning, Darina. Uh, 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 I just lost my. They've changed the chat, right? Chat is now like a window, or somehow the chat window is different now from it. So it's like throwing me off. Well, everything throws me off. So good morning, Darina. Good morning, Catherine. Good morning, Jean-Pierre. Good morning, Jennifer. Oh, glad to hear it, Ashley. That's cool. Okay. Oh, and right, emoticon, or wait, yes, that's an emoticon, not an emoji. Right. Yes. Okay. Now I'm going to try to click. Am I crazy, or is the chat function different now? Like, didn't it used to somehow I think the chat window is different now, or I don't know. Okay. Pop out. Anyway.
It seems the same for me.
Oh yeah. It's okay. Maybe I'm doing. Okay. Well, so I'm crazy. If the other option is, or am I crazy? I guess we know what the answer is to that anyway. Okay, cool. But thank you for answering. I totally appreciate it. That's like 50 points right there. All right. Okay, so let me start with like bad news, good news, bad news, good news, spazzy news. Oh, right. That's it. Thank you, Kath. Okay. That makes that okay. Thank you. I mean, thank you also, person who said that before, but which I actually don't know if that was Ashley or who, but yes, okay, that would explain. Right. Thank you. Okay. Also, again, if I've never mentioned this before, if you're ever really bored or whatever, and there's a YouTuber, I don't know if he's still around. I mean, I learned about this YouTuber like when I was first learning about YouTubers from my now 17-year-old son. There's a YouTuber named Gus Johnson, I think is his name. I think it's Gus Johnson. He's very funny. I mean, I think he's funny. I mean, and he's not really trying to appeal to my age group, but he's just ridiculous, and he does satires and but and I'm sure I've mentioned this, but there's one, if you ever look him up, again, I think his name is Gus, and this is just completely off the wall, but he does this one satire called How to Be a Professor, How to Be a College Professor or something. And he, pretends to be a professor, and he's completely making fun of professors and completely savaging them. And particularly he savages like how bad professor relationships with technology tends to be, like that, and like they don't even know how to click, and they don't know, like, just like it's a professor like showing, and this is before COVID, so it's like a professor in a room but trying to put something on the screen for the class, like put a YouTube on or something like that, and the professor's completely incompetent at doing that, and it's so dead on, and it's so embarrassingly true. And like, and I'm even a science professor, right? And like, I can't anyway. All right, but I recommend it if you're feeling the hate. But right, so I should have realized if I'm in full screen, it's different. That makes a lot of sense. Okay. All right. So listen, on the one hand, okay, there's many catch-up things here. I still don't have your exams. I am humiliated. I mean, I'm a bad person. You will get your exams back, I promise. And I mean, you'll get the grades, you'll get writing all over them. You will, it'll be soon-ish, I think. For whatever it's worth, partly with a stall is that there was another class that took an exam before you, and I took too long with their exams, but then they just finally got theirs back. And if you're worried about your grade, or if the grade is devastating, we'll talk about that, and there will be an opportunity for rectification. Like, I know we're getting close to the end of the semester, and I know this is making people nervous, and I do apologize. It is the reality. I don't have them yet. I will have them soon. I will also say, again, just in case anybody's wondering, or I probably said this before, however you ended up doing on the exam, and I hope you did well. And I also know in the back of my mind, if I take this long, you know, when there's a doubt, like benefit of the doubt goes to, you know, if there's anything on the borderline, if I have to make a decision whether to take off 1 point or 2 points here or there, you know, I'm more likely to take off 1, not 2, having taken this long. Believe me, I know all that. But also just so you know, and I don't want to overhype this, but if you're concerned about your grades and stuff like that, just know that your final exam will be the same system. Like, of course, you may not know if you like this system or not until you get your grade, but the final exam, just so you know, because I know we're getting close there too. The final exam, you will also know everything that's on it before you take it. Like, you will have a practice exam, even if we don't have as much time to sit there and talk about it in class as we did last time, but you will have a practice document and it will have solutions to it, or anything that it doesn't have solutions. I'm saying this quick, just to, I know I wasn't here Monday, so we'll address that in a second too. But just so you know, as we get closer to final exams, it will be the same deal where I'm going to give you a practice exam so you'll know what the exam looks like before you even get it. Anything in that practice exam that I don't literally give you an answer for or solution for, you'll know for a fact that that means it's going to appear verbatim, like nothing changed. Like, so if there's a problem on your practice exam for your final, and if I don't give you a full solution, or if I don't give you answers to that problem, that means, okay, that exact problem will be on your final exam. So you have that much more time to prepare for it, to try to figure out answers to it, to talk with each other, to go on the web, blah, blah, blah. Your final exam went, and again, I'm just bringing this up now because I'm sure people, or some people might be nervous about their grades. When the final, how the final exam will work is like pretty much in the last day of classes, or that, which I know is like 2 weeks or something, but when classes end that week, say that Thursday or whatever, pretty much that day I'll post the final exam like online in Google Classroom, and then you'll have the whole final exam period the whole final exam week to do it at home, same way as last time, with the internet, with your friends, with your Uncle Sam, who's like a physicist or whatever. And then you will turn in your final exam to Google Classroom on pretty much the last day of finals. In other words, whenever the physics final exam is supposed to be does not matter to you. Like, even if we're scheduled for a Wednesday or blah, blah, we're not meeting for a final exam. We're not having webcams or anything like that. You will this will all be in Google Classroom, but you'll have a due date for your final exam, which will pretty much be like the last day of finals. So again, just like before, you're going to do it at home on your own time, under your own conditions. You're going to try to, maybe do a rough draft on your own first and do all the scratch work, and then present me with a final copy in Google Classroom, one document. Again, when I will get your exams back, and we will have a chance, I promise, when I get your exams back, even if it takes a full period or whatever, I will tell you all, like, okay, in general, you guys pretty much did this right. Do the exact same thing on the final exam. Or if I have some big issue, if I feel like, no, everybody missed the point of how to do this, I will tell you, and I'll say, please, on the final exam, you've got to blah, blah, blah. Okay. So in other words, the midterm, it's taking me too long. It is, but it's not going to just go to waste. It's not going to just be, when you get it, it will be your guide to how to rock the final exam. And then I will also remind you as we get closer exactly how all the grading in the class works. But the quick thing to say right now, and I'm just saying all this because I know you're waiting for your exams and you deserve them. But also, let me just remind you the general overview of how the grading works in physics. And this is in the syllabus, of course, but just remember, at the end of the day, you get a grade on your midterm exam when you do. You get a grade on your final exam. They'll be averaged together. So that'll be one kind of exam grade, right? But then all the points that you accumulated on all of these homeworks and all of these game assignments, which you can still turn in, please, 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 like they won't be late or whatever. And even though technically they're all optional, so let me back up for a second. If it turns out that you got 100, on the midterm, and you get 100 on the final or something like that, or you get like 95s on both, then all the homeworks you don't even care. Like, then, okay, you've got an A in the class and you're solid, and that's fine. But in case your grade is lower than you want it to be on the exams, remember that all of the points that you get on all of the homeworks that you have turned in or will have turned in, they all just add up to a pile of points. And that pile of points just gets added onto your exam grade. Okay. So, and if you've been doing a lot of those homeworks, I mean, even those game assignments that are simple, but if you have a big pile of points, I mean, we divide it by a number at the end, like you might have like 250 homework points or something like that. Well, then at the end of the semester, we take the 250, we divide it by one common scaling factor. Like we'll divide it by, say, 25. I can't, that number changes every semester, but it does not change from student to student. It's one number. We divide all the homework points by one number. So say you accumulated 250, I'm just making up. Say you accumulated 250 homework points, and that this semester the number is, let's say, 25, that would mean we would divide your 250 by 25. That means you have 10 points that you accumulated from homework. That 10 literally gets added on to your exam grade, to your exam average. So if you average, like if you have like a, an 80, because you got a 90 on the midterm and you got a 70 on the final or something like that. So if you have an 80 as your exam average, then you get 10 points added to that from all your homeworks. Again, the total amount it depends how much homework you did, but a typical number each semester, a typical number of homework points that a typical average person gets is around 10 or 11. Like some people get like 14 or 15, some people get like 8. But you'll typically, if you've been doing your homework, and I'm talking about just those game assignments, you'll get like 10 points or something from all of your homework accumulation that will be added on to your test average. So say you had an 8, I shouldn't be saying all this right now, but again, just something I can tell you all just to assure anybody. If your exam average between the midterm and the final is like an 80, but then you'll get like 10 points from homework, so now you have a 90. Okay, that's, first of all, that's already an A-, as you know, but then also everything you did in lab. Oh, I'm sorry, I misspoke. Sorry. I mean, everything I'm saying is right, except I left out one big piece. You take your midterm exam, your final exam, and your lab average, because that counts as a third. So all the work you've done for Professor Wu, like once it's all averaged up, all your lab reports, whatever, say your average in Professor Wu, by the time you're done with Professor Wu, say your average there is an 80, which it's generally that or higher. Like most people at least are getting Bs in lab usually. But say you got like an 80 there, and you got a 70 on the midterm, and you got a 90 on the final, then it's like a 70, an 80, 90, they get averaged together. You have an 80, then we add 10 points to that from your homework or whatever. Now you have a 90, and that would be your grade, like, which is an A-. So I guess this is just a long way of just reminding you how the grading works, reminding you that your lab counts for a lot, and most of you do well in lab, and reminding you that every bit of homework you're doing is just adding points onto your average in a significant way. So just and when we go into the final, you're going to do it the same way we did the midterm. I'm just reminding of all this because I know I still owe you numbers, so the least I could do is give you words. So that's the deal with, but we'll talk more in detail about that when I actually give you the midterms back, and I'm sorry I still don't have them. Let me also say, speaking of homework, I wasn't here Monday. I apologize. Or I canceled class Monday. I apologize for the short notice. Where we are in the curriculum is I'm trying to drill free body. Oh, sorry. Yeah, I mean, good question. I think this weekend is the most realistic answer. I mean, I keep saying soon, and then it keeps getting pushed. So I'm afraid to say something and then it push again. But I think this weekend, really. I mean, I've fallen behind, and I apologize. But I don't believe you're going to have to wait till Monday. I believe this weekend you'll have the grades for the midterm. And I'll say this too. I'm not holding on to them. I promise. I'm just trying to finish them. But when you get them, you're just going to get your whole midterm back with a grade on it. I'm not going to just give you the grade or something like that. I'm going to return each midterm with all the comments and the grade on it. And I believe you'll get them this weekend. And I apologize it's taken so long, but I believe this weekend. You will definitely get them back before you have to take a final or anything like that. You'll need to know, you'll have a chance to benefit from the experience before you take the final. But yes, I apologize that it's taking so long. But as far as now, so Monday, we didn't have class. What we were going to do, and what we're in the middle of now is dealing with free body diagrams, forces, Newton's laws. What I'm going to say is, it turns out, how can I say this? So I don't want you to have missed any curricular time just because I wasn't here Monday. On the other hand, I don't want to punish you for the fact that I wasn't here Monday. So the simplest, best thing to do about the Monday material is this. The topic right now is free body diagrams. That's what we're dealing with. That's what are really necessary, for example, for lab 5, which I want to hear about in a moment. It turns out in physics 204, okay, they had a midterm exam somewhat recently, and they're studying different things in physics 204, of course, but Newton's laws never go away, and free body diagrams never go away in physics. They are a fundamental part of physics, like for the rest of our physics lives. So it turns out, I'm just telling you, like, honestly and realistically, on their midterm, even though their midterm wasn't explicitly about free body diagrams or anything, there were pieces in their midterm where they had to do free body diagrams just to figure things out. And I came to realize, looking at their midterms, that there was still some unfortunate confusion in physics 204 regarding free body diagrams. And that makes it difficult. Like, it's something you really want to have straight as you move on, even if the last course you ever take is physics 204. So when I found that out, when I realized, oh, they're still confused about free body diagrams and this is going to get them in trouble somehow, I did a whole class with them, backing up and starting free body diagrams again and trying to really go through how to do them. Okay, and I made a video about that. You might have noticed in Google Classroom. What I'm trying to explain right now is, in order to make up the curricular time that we missed Monday, like I can't, in order to make up that time, but without us losing any more time, the video that I made, I made a video of free body diagrams, like from top to bottom. I put it in the 20, even though it's called like FBDs jjP203 or something, I put it in the 203 playlist on YouTube. And more specifically, hopefully you'll see or you'll notice, I put it in your Google Classroom thing and made it into a 75-point assignment. Let me try to say this slowly and carefully. Like, you know how we have the game assignment every class where you're supposed to just write a sentence about your class participation. Like we have one for today, you know, just, and again, it's optional, but if you just take a moment, you'll get 50 points for today. Well, instead of, so for Monday, we weren't here. There's no way you could have participated. But if you look in the Google Classroom, you'll see what hopefully is not too confusing. I made your game assignment that would have been from Monday. I made it due this Sunday, and I made it for 75 points rather than 50. Or no, I think I made it for 80 points rather than 50. Oh, you can see, thank you. Great. Thank you, Catherine. That's like a lot of points for Catherine right there. But thank you, Catherine. Yes. Okay. So that 80-point assignment, which might be a little confusing, what it's basically saying is you've got till Sunday to watch the video that I attached there and that I also put in your YouTube folder or whatever. Here's something, I'm sorry. If you it's like an hour and 15 minutes, whatever, but I'm asking you to watch that video and I'm going to look. Okay, I'm going to look at that in 1 second, the chat. Let me just say this sentence before I confuse myself. So I'm saying, instead of the typical Monday thing that would have been due Monday at 1 p.m. where you just like write a sentence and you get 50 points, I'm saying you have till this Sunday to just please watch that video and then just give me one sentence about that video, like, as a way of like showing that you watched it or whatever. Give me either a question or a comment or just like something, I mean, I'm not trying to track you down and you can't prove to me whether you watched every minute attentively or not. And I'm not trying to enforce that. But just if by this Sunday evening, you can give me one sentence about that video to sort of indicate that you did at least attempt to watch it, then A, you'll get 80 points for that instead of 50. B, that's my way of making up the class time, the curricular time for you. It'll save us time if you watch that video and I don't have to go through all that again here. So that's the deal with that. Let me just look in the chat because I see there's at least one question about that in the chat. Hold on. Is there still, if you're under the typical, oh wait, okay, Antonio's question, I think this is a very important, so Antonio's question in the chat, I think it's very important and very legitimate. I might be misunderstanding it. If you're under the typical, okay, I think this is, so what he wrote, I mean, you can read it, but it says, if you're under the typical extra points, is there still a division? Oh, so I think the answer is yes. Let me try to answer it. There's definitely any questions about your grades are fair and important. So I definitely want to answer them. I think I can answer this. So let me say this more slowly. Like at the end of the semester, each one of you will have a whole bunch of homework points all accumulated, right? Like, and it's tons. It'll be like in the thousands or something, right? Because you got like for every single day. Many of you, like every single day have submitted. you know, the game thing. So you're getting, like many of you are getting like 50 points for every class period. And some of you are getting 50 points for every other class period, whatever. But you'll have this big pile of points. Now, what I'm saying is we, like the physics faculty, every semester, after we have all the grades in, after we have all the grading data in front of us, we look at the grading data and we come up with a scaling factor. So I'm saying this slowly. I know I haven't answered Antonio's question yet. Like this is about to be an answer to his question. Every semester we look at all the numbers and we come up with a scaling factor. And I'll tell you how we come up with that in a moment, but it's based on the numbers we look at. So it's a different scaling factor every semester. But whatever the scaling factor is that we come up with is the same for every single student. And so say the scaling factor this semester, say we come up with like that we have to divide by 25, which I think was the example before. Then yes, what I'm saying to Antonio and to everybody else is then every single person, no matter how many points they got accumulated for homework, no matter how many points they got, we're going to take that number and divide it, that total amount of accumulated homework points, and we're going to divide it by 25, no matter who you are. Even if you got 0, then we're going to divide 0 by 25. Now, no one's going to get negative points, right? This is the thing about homework is they're not percentages, and they are like, you can't get deducted for doing homework badly or for not doing it at all. But what you get is just points for doing homework. So no matter how many points you accumulated through homework, yes, no matter who you are, whether you're under the typical or over the typical or whatever, we're going to divide your total by 25 or whatever the number is. And I'll explain why. But before I even explain anything further, the reason, well, I guess I am explaining why. We do that to everybody because, again, remember, like you're going to get, like even if you only did 10 homeworks, right? Which would mean, I mean, we've had a lot more classes than 10, but even if you only did 10 homeworks, then you have 500 homework points. Well, we can't add 500 points to your average. Like that literally doesn't make any sense, right? And so frankly, put it this way, even if you only did 2 homeworks the whole semester, which is definitely not true of Antonio, I can say that. And I don't think it's true of almost anybody in this room, but even if you only did 2 homeworks the whole semester, well, that would be 100 points right there. There's no way we can add 100 points to your average and have that be fair. Like you can't get an A+ in this class or an A in this class for doing nothing at all and just doing 2 homeworks, right? So we have to divide. In other words, maybe this whole system would be better if the homeworks were only worth 5 points rather than 50, but they are worth 50. So we have to divide everybody by something to scale it down to make it a reasonable number of points that can affect your grade. So yes, no matter who you are, your homework total will be divided by the dividing number, the one dividing number that we come up with for all students. And that's the sense in which it's fair. How do we come up with this number though? The way we come up with this number is we look at all the grades, the exam grades without the number, and we come up with a number that makes sure that people get, that we come up with a number that will make sure that people get A's. So this is our secret curve, frankly. What we do is we use your homework as a curving lever on your whole grade. Like the amount your grade gets curved is by virtue of your homework. So people that do more homework do get more of a bump to their grade because they did more homework. But what the homework is doing is raising everybody's grade, and we are raising from what it would be from just raw test averages, because we know people have bad testing days or testing is difficult. Testing is not the only way to engage in this class, blah, blah, blah. So yes, whatever dividing number we come up with applies to everybody, but we come up with a number that makes sure that, so in other words, if the person in the class, the highest anybody ever got on an exam was an 80, which is not what's going to happen. But if say the highest exam grade in this whole class was an 80, exam average, like that, say that for whatever reason this semester, and again, I know for a fact this is not happening, but say nobody did higher than an 80 on the midterm and no one did higher than 80 on the final, and no one did better than 80 in the lab for some reason, right? So the highest grade was an 80. Well, that person's getting an A. Okay, because they got the highest grade in the whole class, and the fact that nobody could get 100 is our fault, not yours, basically, is the way we think about it. Like someone should be able to get an A in this class. So, I mean, just like a standard curve that you've heard of in other classes. So we will pick a number we'll pick a dividing number to make sure that at least everybody who got 80s or something is getting an A, and probably more than them. So believe me, we pick a number that's meant to be generous. It's meant to make sure that if nobody looks like they're getting an A in this class, then that's our fault, not your fault. Like whoever got the highest grade should get an A in this class. I mean, it's the simple way of thinking. So we use the homework as our secret, it's not secret, but as our back of the room lever for curving all the grades. By the way, because technically we're not allowed to curve. I don't know if anybody knows that. And I'm sure you do have curves in all your other classes, but technically in the science department, at least last time I checked, we're not supposed to curve. So technically we're not curving. We're just giving you extra credit for homework doing. But this is also why, just so you know, even though I'm over talking this because I haven't even given you midterms back, but we don't actually curve the exams. We give you the score that you got on the exam so you can see it. We do give extra credit. We will give extra credit for things like we will give points back on the exam. You'll see, I mean, there won't be a lot of time, but we will. Sometimes we even do test corrections. I don't think there's gonna be a lot of time for that in this class, but believe me, you'll be able to get some extra points back on the exam. We believe in all that stuff. We, meaning the physics program, we believe that people should be able to get an A in our class. If they can't, we're doing something wrong, right? But we don't technically curve the exams. We curve, if you want to call it that, your whole grade at the end. That's what I'm, so I hope that makes some sense. That's why I'm still telling you all, if you have back, game assignments, you can, or any kind, you can still turn them in. I mean, we want you to get as many points as you can. And one last thing, I see there's other stuff in the chat. And again, I don't mind talking about all this. I think, you all have, I know how important it is. It's a little stupid of me to be talking about it so much when you don't even have your grades on the exam sitting in front of you. I'm sure I'm overcompensating right now for my guilt in that fact. This will all make more sense once you're looking at the numbers. And many of you, once you see those numbers, many of you are going to be like, oh, cool, I got a 90 on this test or whatever. And then you're going to possibly believe that this whole homework discussion is irrelevant to you. And you're right, like grade wise, you're right. If you just get 90s on all the exams in this class, then you don't even need that extra. I mean, you're still going to get those extra points, but you won't even care. And that's fine too. Basically, another way of putting everything I'm saying is there should be, I guess this is another, the last two ways to put this, again, just in case there's any anxiety in the room. And if there isn't, and I'm creating it by talking about this, then I apologize and we'll move on. But I think you have the right to care about your grades. I think you have the right to be graded fairly, but compassionately. So another way to put my view of grades is, first of all, I always need you to know, and this is true in Physics 204 as well, which is a harder class, but the same policies apply. And that's this. I need you guys at all times to know whatever's going on with the grading or the grades, I do not believe that some people have to fail in order for it to be a legitimate class. I do not believe that if everybody did get an A, that it's not a legitimate class. Like I'm not, but I do believe that if nobody gets an A, that something's wrong on my part. So, and fourth, I believe that in order for people to get A's in the class, there should be more than one way to get an A in this class. Like we shouldn't only be able to get an A because we're good test takers. We shouldn't only be able to get an A because we talk every day in class. Like different ways of engaging should be rewarded, in my view. There should be more than one road to the destination of A. And I should be here to be trying to help as much as I can to make sure there are as many A's as possible, like to help fairly, of course, right? But I should not be on the other team blocking you from your A, and there shouldn't only be one magical way to get an A. In the end of the day, after saying all this, I can say that every semester, somehow or other, some people do find a way to fail. And that's actually what keeps the whole system going. Like even with all these policies in place, there are always some people that don't do anything, for whatever reason, sometimes legitimate reason, sometimes not. But there's always some people that even with all these systems in place will still literally give me nothing, no way for me to record an A for them. And that's really unfortunate for those people, but it's also why all the rest of the people can know that it's a legitimate system. It's just like how you'll know when you finish this John Jay forensic science or whatever program you're in, but when you finish this tough John Jay science program, and I think I've said this before, this major, you'll know that your degree really means something and that you really did earn it and that you really should be proud and you're going to get a good job or a good research post or good graduate school because some people don't make it through the John Jay Science program. That's what shows that it's actually a real program, that in fact, it is just hard enough and just real enough that people don't automatically get through it just for paying tuition. And same thing with this class. There's a million ways, I hope, to get an A, and I want you all to get A's, but the reason it's not just a gift or the reason it's not a BS class is that somehow or other, with all those systems in place, still there will be every semester just enough people to get a D or an F that it actually means that the rest of you, if you did get an A or something, you can be proud and know that it was not a gift, it was a system. And it kind of does end up working like that, by the way. There aren't usually a lot of C's or B minuses. It's usually more like you either rock it or you don't. But all right, let me look in the chat. I know I'm saying way too much about this if you don't even have the things in front of you. But okay. No, so yes, I'm looking at the direct. Yes, please, you can still submit old game assignments. Like, as long as you're honest and authentic about it. Like, pick days where look at your records, look at the class notes. Like, one thing I am a little bit proud of, or I'm a little bit defensive about, is if you ever do look in the Google Classroom, you'll see that every single class that we've had has both the notes from that day and the video from that day posted. So you can go back to any class and just briefly remind yourself, like, just look at the notes. Hopefully you have your own notes too. I really do hope, but you can look at the class notes or the YouTube from any given day and just remind yourself of what that day was. And then if you authentically, and know too that I have those records. And of course I have all the chat records and everything from Zoom from all this. So, I mean, if I really thought someone was making a practice out of lying to me, believe me, I would know and I would look into it. But it is definitely not too late. If you go back to old classes, and particularly you remember one, I think right now it would be a little bit bad form to suddenly now submit every single old class to me. I think it would be hard to believe and hard to accept. But if you've got a few from weeks ago and you check and you know what day we did what, and you remember that you said blah, 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 or you have the chat records. I don't even know how that works on your end on Zoom, but if you've got the chat text file log thing, then by all means, yes, you should, any of you can and should still retro hand in any game assignment if you're being honest and authentic about it. Like, and I can tell the difference. But yes, please, especially, by the way, that's half the point is if someone right now, not right in the middle of this day, but if someone tonight or this weekend, or maybe next week when you get your exam back, if you're all of a sudden panicked or something, if you sat and like went through all the old classes to remember what they were about and to remind yourself whether you did or did not participate, of course, that's awesome, right? Like, that's good for the final, and that's like my dream come true. Anybody would sit down and like review the prior classes and see what they do understand and what they don't. I mean, that's a great thing. So if the opportunity to retro hand in your game assignments forces you to do that, then we both win. So yes, the answer, I'm answering a question that's in the private chat. Yes, you can still turn those things in. Just don't be ridiculous or abusive or blatantly dishonest about it, because that will catch up with you. But yes, and everything I just said also applies to the regular homeworks. Like, yes, you really can. Unless I took off the link, if the link is still there, you can. If it's super old, like if it's like homework 1, maybe I might not give you full credit. Maybe I might dock some points, but so what? You'll still get more credit than not. And again, there you have to be authentic. Like with the old homeworks, we have gone over most of them in class at this point. So what I would expect is that you would in fact benefit from that at this point, that your homework would reveal that you now know the material better because you were in class. But believe me, all of y'all, I know the difference between someone just like copying the answers at this point from somebody else or from the notes versus someone looking at someone else's and looking at the notes and authentically doing it now. Believe me, I know the difference. And back in the day before COVID, it is true that the night of the end of the semester, I would often in my office, I would get these huge packets of all the old homeworks, like all stapled together and slid under my door on the last day because I said I would still accept. And believe me, if I get a whole packet of every single old homework, all stapled together and slid under my door, and if I open that packet, and this used to happen, I would open that packet and then surprise, surprise, every single homework was done in the exact same pen, in the exact same handwriting, and all perfect. like no scratch outs, no thinking, no draft, like scratch work, just perfect answers to every single homework, all in the same blue ink, all in the same handwriting, all stapled together with the same like date 1, date 2, date. Okay, that was obviously ridiculous. Like obviously the person just like the night before just copied all the homeworks from their friend and like didn't even bother to try to make them look thoughtful. Well, that's an insult to my intelligence. Like, of course I see what's going on when that happens. And then if you do that, you're just wasting your own time because I'm not going to give credit to all that. And we're not even going to have time to have a discussion about it by the time that like you're going to think you did all that instead of studying for the final. And I'm just going to be like, thanks, and maybe give you 2 points. And then that was like, don't do that. Just be, the point is be honest. I believe in better late than never. I believe in that no one, the clock should not run out on people just when I feel like it. Like, I believe that most people do not learn any of this stuff the first time around. You have to keep going back around it. So that's why the better late than never. But don't BS me, or don't BS yourself and BS me because it is transparent. I mean, it is, and it's pointless. But okay, so yeah. So as long as you're honest about it, yes, you can turn in old, regular, everyday homeworks, absolutely, and especially if you think they're going to help you with the final. Okay. Sorry. But yes. All right. So that was 2 questions direct chat, hopefully. And you can keep these questions coming. I mean, I don't mean to, again, I think they'll probably be more concrete for many of you once you actually have your grades back. But if all of you ended up with an A in this class, that would not upset me. And especially if it was a legitimate A, it would make me happy. Okay, we're on the same, we're both rooting for you all to get A's because you learned this stuff. And we both, me and you, both, well, I believe there's more than one way to learn this stuff. And I also believe that no one actually learns it really the first time through. I think that's a huge mistake we make in science education, is expecting to think that people get things the first time they hear them. Absolutely not. Absolutely not. So so whatever that means. Okay. So that's sort of clear. So what's the upshot of all that? I still owe you your exams and I apologize. That is on me. On the other hand, as far as the class that we missed Monday, please, when you get a chance between now and Sunday night, watch the video, jot down a sentence that somehow indicates that you watched the video, like say something about from the middle or something, and you'll get 80 points for that. And then I'll also know the material's covered and we'll go on. Now I want to go back to the material now, but I actually want to ask you a question. Speaking of material, I want to make sure I'm in the right place. With regard to Professor Wu and lab, have you, what I consider to be, oh, I keep saying lab 5. But yeah, in my mind, lab number 5 is the one that at least we generally call slow down. Lab 5 is the one where where something's going up and then it comes down. Can I just ask for your input for a moment? First of all, have you done that lab? Do you know the lab I'm talking about? Lab, like the up and down the plane?
We haven't done it yet. And then like that's like the next one coming up, but we haven't done it yet.
Oh, that's very helpful. Okay, thank you. I mean, that's like true. And by the way, every single one of you, oh, okay, wait, I'm looking, thank you for all, that was fast participation on that. You all get points for this. Thank you. Wait, I'm looking in the chat. He mentioned you aren't doing, oh, you aren't doing reports on it. Oh, okay, okay. Oh, okay. So the very last thing you did was lab 4, then the ballistic projectile. Is that correct?
Yes.
Yes. Okay. And for that, you're just supposed to do the steps in the analysis. Okay. Okay. All right. That's good. So then, okay, well, that's actually perfect. Okay. So what I'm going to talk about today ultimately relates to the lab 5. I mean, I think I've said a lot about lab 4, and I think in a way you've already been sort of tested on it in the midterm and all that. So if lab 5 is coming up, what I'm going to say today is hopefully going to help a lot with lab 5. But I'm reading you loud and clear that if you're not going to do a report on it, okay, then I won't get too fired up. But okay, that's good. That's helpful for me. And again, every single one of you that just like say, even if you just wrote yes, I don't mean just, but like you know, everyone, Noelia, Jitlali, Catherine, Alyssa, like all of you totally, Jennifer, David, should all, Catherine, you totally should, you know, put that in a 50 point or in a 7, you know what I'm saying, in a game assignment for today. Okay. What I want to continue talking about then is free body diagrams. Again, that's what the video will help you with too. I want to pick up from where we were last week. So here, the notes I'm flipping through right here, this is notes you already have from last week, but I'm going to, in the same packet, I'm going to continue doing the notes today. So just to remind you, I was beginning to talk to you about free body diagrams. Free body diagrams are the way that we identify and quantify all the forces acting on an object, on a mass, at any given point in time, at any given point in space. Okay, so and again, this is like a skill that we need for the rest of physics. You totally do need it for lab 5, whatever is going to be expected of you in lab 5. And what I was analyzing last week, if you recall, like right here on the screen, I was analyzing the case of free fall, because free fall is, in a way, well, it is the simplest possible case of a force acting on an object, because it's only one force. Free fall means just one force, the force of gravity acting on an object, and the force of gravity is always here on planet Earth. So there's no free body diagram in the world that doesn't have gravity indicated in it. So we had started by saying if something's in, so I had started by saying that in a free body diagram, you draw a dot representing the mass itself, the mass that's in question. And you draw one arrow for every single force acting on the object. And the first arrow that you always draw, the first force that's always there, is the force of gravity, which I was saying, and sometimes that's the only force. If it's the only force, then that's what we call free fall, right? Now, last week, I was saying, okay, one word for the force of gravity is the word weight. That weight really means, right, the force of gravity. It is a force. It is measured in the same units that all forces are measured in, which are newtons. 1 Newton equals 1 kilogram times 1 meter per second squared. Again, that's what I was saying last week. Okay, so I'm just reminding you. So the free body diagram of something in free fall technically would just be one arrow pointing down, and that arrow could be labeled weight. But then we went further and said, okay, here's the thing. Let's apply Newton's second law for the first time here. In this case, Newton's second law, the thing in red here on the screen, Newton's second law says add up all the forces acting on an object, add up all the forces acting on an object, take into account axes, take into account direction, and along each axis, if you take into account direction, the sum of all those forces acting on that axis will produce the acceleration of the object along that axis. So in this case of free fall, there was only one force, and that force is called weight, right? But in the case of free fall, we happen to have this knowledge already. Like normally we're using forces to predict accelerations, but in the case of free fall, we already know from like lab 2, from homework 1, from homework whatever, and from just having stopwatches and living in the real world, we already know that anything that falls, free falls at a constant acceleration rate of essentially 9.8 meters per second squared, whatever it is we call it, lowercase g. So we were able to say, and this is a big conclusion from last week, that from here on in, the weight of any object m, if you have any mass m, any number of kilograms, the weight of that object will automatically be its mass times 9.8 meters per second squared, right? So if you have a mass of 1 kilogram, it automatically has a weight of 9.8 newtons. That's what we're saying. If you have a mass of 2 kilograms, it automatically has a weight of 19.6 newtons, and in many cases, we could just round that to 20. And the important thing about this, as I'm saying, is from here on in, then that's the weight of an object. We learn this from free fall, but it's true whether or not an object is in free fall. Like every object always has the earth pulling down on it, even if the object also has other things pushing or pulling on it. So what I'm now going to do, we're going to start making free body diagrams. Oh, sorry. Right. Good, Aja. Yeah, the weight of an object won't change. Well, let me make sure I know what she means by that. I am saying from now on, I think it's on the next. Okay. Yeah, I am saying from now on that any object you have m, any mass you have whose mass is called m, its weight is automatically mg. Like I'll put it this way. I am definitely saying, sorry. I am saying So I am saying if I know the mass of something on Earth, then I automatically know its weight is mg. I am saying that no matter what, you multiply the thing's mass by 9.8 meters per second squared, and you'll get its weight in newtons. I am saying that will not change. And I'm saying that will not change even if you put the object on a table, and we're about to see that right now. Like, even if it's not in free fall, it's true. Now, if Aji is asking also, like, does that mean that your weight is the same here on Earth as it is on the moon? Well, that's a great question too. And what I'm really saying there is even on the moon, if your mass is m, then your weight is still mg, but it would be the g that applies to the moon. Like, in other words, g, the acceleration at which things fall on the moon is more, I'll write this down just to make this clear. Here, how about this? Okay, so I think this may be part of what Aji, oh, and I'm going to look in the chat in 1 second, sorry. So I may be either under answering this or over answering this, but to be totally clear, weight is mg no matter what, but the value of g will change from Earth to the moon or to Jupiter. Excuse me, like on Jupiter, g is really, really high number. Excuse me. Like Jupiter is really, really massive. So it pulls things toward it really intensely, more than Earth does. So the G number on Jupiter is really, really high. On the moon, and we'll get more into this like in Physics 204, but on the moon is much less massive than Earth. So it pulls things to it just like Earth does, but it pulls things more weakly, less strongly. So on the moon, the G number is like 1.16. I mean, these are real numbers. I'm not making them up. But I'm calling them approximate. I'm using the approximate equal sign because these numbers actually go on forever without repeat, like the number pi or something. So we're chopping off digits, but so the G number changes from place to place in the universe. Therefore, it is true. And again, I think this might be what Aji is getting at. So my mass is the same here and on Earth. What does that really mean? It means it's equally difficult to throw me horizontally here as it is on the moon. If you want to shove me to the left and you want to get me up to a certain speed, you're going to have to shove me the exact same strength here on Earth as on the moon. If you want to shove me to the left or to the right, but if you want to throw me up and watch the rate at which I come down, that's different on the moon and on the Earth. So my mass is the same on Earth and on the moon. My weight is the same formula, mg, both cases, but the value of g will change from the Earth to the moon. So therefore, my weight will change. And one last thing, and then I'll look in the chat. Again, mass is measured in kilograms. It is your resistance to acceleration, period. Weight is measured in newtons. It is specifically the force of gravity pulling down on you. That's what weight is. And it is mg. We just derived last week. It's mg no matter what, but what g is differs. Okay, I probably said that too many times. Let me just look in the chat and make sure that's what you're asking. Right, exactly. Okay, so exactly what Catherine said is the point. And of course, if I had read that 5 minutes ago, I probably could have saved you all a lot of hassle. But yes, so good question, Ajay, and good answer, Catherine. Okay. So now what I want to say is, let's start looking at situations that are more complicated than free fall. Let's look at free body diagrams and accelerations for more complicated situations, ultimately like the situation in lab 5, which is actually quite a complicated situation. Okay. Okay, well, that's, oh my God, that is really distorted, but okay. Let's say we have a coffee cup of mass M sitting on a table, okay? So this is like the next level of complexity that's possible. It's not that complex, but so it's no longer a free fall. And let's say the coffee cup has a mass of M, okay? So first of all, that's just a rough sketch just to show you what I'm talking about. That's not a free body diagram or anything. It's just like a, you know, sketch of the situation. If I want the free body diagram. So again, I'm trying to explain this. I started this last week. I'm trying to explain this more. Believe me, I'm aware. I still want, like, I'm trying to give one sense of free body diagrams are super important. So I'm trying to give you one perspective on them right now, but the video is going to give you more perspective and a different perspective. And especially if anything ever is due with Lab 5, you're really going to want to see that video. But anyway, and also for, it'll help you for next semester. But anyway, the free body diagram of the situation. Well, I'm supposed to draw a dot. Sorry, I'm supposed to draw a dot representing like the center of the coffee cup, representing that mass, the coffee cup M. Okay. Now I'm supposed to draw, the whole idea behind the free body diagram is to draw a vector arrow for each and every force acting, I do this every time, on the mass. Sorry, so I'm gonna move this down. So I draw a dot representing the mass. Now the idea behind the free body diagram is to draw an arrow for every single force acting on the mass. So the big question becomes, well, how do I know what forces are acting on the mass? Good question. Well, first of all, we always before we do anything else, we draw an arrow representing the weight of the object, because, and this is the point of the whole discussion from Wednesday and from the 2 questions I just got, like every single object has weight. I mean, especially if it has mass, it automatically has weight. Gravity's automatically pulling down on it. It's always there. So we always draw that first and we label it mg. Okay. We're not done, but that's the first thing we put into the diagram every single time. Now, next, so and that's like a rule. But then what we're going to, like, now we have to draw the rest of the forces. There are other forces in this situation. How do we know what to draw? After we've drawn gravity, we look at anything and everything touching the object. And it is honestly that simple. It's so simple that people get it wrong all the time. The way to identify forces is to look for touches. And vice versa. If you think there's a force, ask yourself, is something touching it? Similarly, if you see anything touching the object at all, then there's a force. Okay, so 2. And I literally mean touches, like physical contact. And the reason I want to make a big point, this is also why we always put gravity in first. Gravity is like the exception to this rule. Gravity is the one force we seem to know about in classical mechanics that seems to be able to act without touching. That's what makes it very mysterious and very weird. So weird, in fact, that we wouldn't even believe in it at all, except that it's like always there staring us in the face. Gravity seems to be like, gravity is the ability of Earth to pull on things without touching them, or the ability of planets, stars in general, to pull on masses without touching them. Because we see it all the time, we believe it's there. But so we put it in the diagram always. But then after that, that's the weirdness of gravity. Gravity is the only mechanical force that has that property, that can it's the only interaction between two objects that can take place without touching. I mean, magnets also do that, but magnets are not part of mechanics. They're part of physics 204. So what we ask ourselves now is, okay, what's touching the object? And in the case of this example, we have a coffee cup on a desk. We've got a desk or a table, whatever I called it. We've got a surface underneath the object touching the bottom of the coffee cup. Like we've got a desk touching the coffee cup. So I'm going to draw an arrow representing the desk, which is somehow affecting the coffee cup by touching it. So I have to ask myself now, okay, how is it affecting it? Like I'm claiming the desk is either pushing or pulling on the coffee cup. Well, first of all, I think it's pushing. Like here's the coffee cup, here's the desk underneath it. It's definitely touching. Now, first I ask myself, is it pulling or pushing? Well, pulling means like toward and pushing means away. This desk is not pulling the cup down toward it. First of all, the desk is not like a magnet or something weird like that. Second of all, the desk is not like a fishing line. Like it is possible to pull things like with string, but that's not what's happening here. The desk is not a string, it's a surface. This surface is pushing up on the coffee cup. Now you might say, well, I don't see that it's pushing. I just see that it's like touching it, but it is pushing up on the coffee cup if you think about it. And one way I know that the desk is pushing up on the coffee cup is that, you know, if the desk weren't here, the coffee cup would fall down. So clearly, I think it's clear the desk, if you think about it for a minute, the desk is pushing up on the coffee cup. Now, not in an animate way. I'm not saying that there's hands making a decision to do that, but it is pushing up on the coffee cup. So of course, this also shows that I haven't given myself enough room once again. Hold on a second. I'm just going to move this down. So I have one force that represents the weight of the coffee cup. And now I'm going to draw another arrow that's going up. And that represents the force of the desk. Now, for the moment, I'm going to call that desk. Actually, yeah, I'm going to call it desk. Okay, just like in the other diagram, initially, I called the downward arrow gravity in quotes, and I called it weight. But then we eventually found a sort of more tidy abbreviation for that and called it mg. I'm going to get into that same discussion right here in a moment. So I'm just repeating this one. I don't. Okay, number one, I'm putting desk in quotes because that's not ultimately the way we're going to label that arrow. There is a better way to label that arrow that all the textbooks do that we will do in a moment, but I'm holding that thought for the moment. Okay, so that's like frequently asked question number one. Am I really going to like put desk in quotation marks every time? No, I'm not, but just hold that thought for a second. Question two. And sorry, I'm going to just keep redrawing the diagram just so we can look at it while we're talking about this. The diagram I have so far. And by the way, notice like M is not in the diagram. M is that dot. Like the dot always means the M that you're talking about. Also notice I'm not writing coffee or cup anywhere in the diagram. I don't have to, because what we're trying to look at is what are the forces acting on that coffee cup or whatever, okay? And I'm also not drawing anything about velocities or anything like that. This is all about forces. But question number 2 then, was this question 2? Yeah, question 2. Okay, very important. Again, I'm dwelling on like, this is a comparatively simple situation, but if you really understand the simple situation, then the complex situations are just more of the same. I'm saying in this situation of a cup sitting on a table, there's only 2 arrows in the diagram. One downward arrow for gravity, because gravity's always there. And then one upward arrow for the table or the desk, because the desk is another object that is touching our object, our mass. What the standard is that for every touch that we observe, we draw an arrow. Like literally for every touch, there is an arrow. And if there's no touch, there's no arrow, plus gravity. Okay, so in this situation, so literally what we're really doing is counting up or identifying any objects at all that might be interacting with our mass via physical contact. So, I mean, if we were talking about a situation where the coffee cup is on the desk and I were pulling it with my hand to the right or to the left, then we would put my hand in as well. Or if there was a string also, like, you know, pulling up on it, like there can be 1,000 things affecting the cup. But if you want to know how many things are affecting the cup, you have to literally ask yourself, how many things, excuse me, let me say that again. There could be 1,000 forces acting on this cup. But in order to believe that there's 1,000 forces, you'd have to see 999 objects touching the mass in various different ways. And then I say 999 because then there'd be plus planet Earth pulling it gravitationally. So there's no other touches in this situation. There's no other arrows. So this is our whole free body diagram. But let me still go, but there's still more questions to be asked. And I know there's 10 minutes. I'm aware. So I'm aware. So the next question is, so that's our diagram, by the way. If all I asked on an exam or something is draw the free body diagram of a coffee cup sitting on a table, there's our diagram, an arrow up and arrow down. I still want to talk about how to label that upward arrow, but before I even get into that label, let me ask a last question. Okay, so the next question is really in concrete terms. Okay, those two arrows I drew, they are opposite in direction. Like one is straight down and one is straight up. Like that is, I think, a fact. One might ask, am I deliberately making those two arrows equal in length as well? In other words, do I believe that those two forces are equal in magnitude? Now, let me say, first of all, if the answer to one question is yes, then the answer to the other question better be yes. Like if I believe the two forces are equal in magnitude, then yes, the two arrows should be equal in length, and vice versa. So this is a very important question, like the lengths of the arrows. These are strictly speaking supposed to be vectors. So the length of the arrow is supposed to be indicating something about the magnitude of the vector quantity. So it is an important question. And definitely it's true that when you believe arrows are equal in length, that is a huge piece of information, and one should be explicit about it. So let me start by, so that's the question. So let me start by saying that the answer if and only if, so IFF, if and only if we have explicit reason to believe that the forces are equal in magnitude. So if we have explicit reason to believe the forces are equal in magnitude, then, sorry. Then we should So first I want to say, if we really actually do believe the forces are equal, then we really should make the arrows equal, yes. And in fact, we should go a step further. Like it's such an important point that if we really think the arrows are equal, then in fact, what you'll see in a lot of textbooks, and like I like to do, what we should do is in fact make marks on the arrow, like if, this is if. If we really think the two forces are equal, then we should make the arrows equal length and even put like a little mark on each one of them or something saying like, yeah, these are equal. But that's if. If, on the other hand, and I'm not saying that we do here, but on the other hand, but if not, then not. Like meaning, if you're not sure, if you don't actively have a reason to actively believe that two arrows are equal in length, then don't make them equal in length and don't express their equality. And like, in other words, what I want to say before going any further, just because you see two arrows that are opposite in direction does not mean that they have to be equal in length. So if there's doubt in your mind, leave them be. Now, in this case, so this is like answer one. Okay, I sort of did get into this last Wednesday, but let me say here, I mean, this is it's a big pitfall. Just because two arrows are are opposite in direction, that alone does not mean they have to be equal in length. Often people think it does because of Newton's third law. Let me say here in this case, I'm not saying this particularly well, but I'm saying first, there's a thing called Newton's third law. We discussed it last time. It does say if I push you, you push me back with a force of equal magnitude. Newton's third law necessarily always requires two diagrams to express. If I push you, then you push me back. Meaning, if I'm drawing a diagram of you and there's a push on you from me, then there must also be a diagram of me with a push on me from you. Newton's third law is always about two objects interacting with each other and therefore two different diagrams. If you ever see a pair, and I know it's 12:03, so we're going to end on this right now, but if you ever see a pair of forces within one diagram, they might be opposite in direction. They might even be equal magnitude, but they will not be an example of Newton's third law, not if they're in one diagram. In this case, this is where we'll end today. In this case here, and this is to answer all the questions now, to bring full circle. In this case here, this is where we're going to end right here. I'm just going to end right here. Say yes, 12:05. Number one, and this is a subtle point, but in this case, I am saying the two arrows are equal in magnitude. They are. The upward desk arrow is equal to the downward mg arrow. How do I know? Not because of Newton's third law, not because ups always have to equal down, but because I know that A is 0. Because I know the coffee cup is sitting on the table, accelerating at a rate of 0, and I know that there's two forces acting on it, a one up and the other down, they must be balanced. Otherwise, the coffee cup wouldn't be sitting. Put another way, if this coffee cup were on the platform of an elevator and the elevator were accelerating up, then the two forces would not be equal. Because the thing is sitting still, unaccelerated, I believe the two forces are equal. And furthermore, it turns out from now on, we're not going to call that up arrow desk anymore, because it might have been a desk, or it might have been a table, or it might have been a couch, or it might have been a floor. Any kind of horizontal surface that I used at all of this logic would have applied. So from now on, any surface that is pushing perpendicularly against another surface, we're going to call N for normal, because normal in math means perpendicular. I mean, I'll pick up on this on Monday, but from now on, any surface that is pushing perpendicularly against another surface, we're going to call N for normal. Normal means perpendicular, and it refers to surfaces. So in this case, we have N up, mg down, and they are equal and opposite by virtue of Newton's second law, not third law. That's all I have to say today. Sorry to keep you over. Thank you guys for being so patient. Please do the video thingy, bedaddle. Thank you. Thank you very much. Awesome. Thank you guys. Awesome. Awesome. You guys are the best. All right, great. And I'll post this and all that. Bye. I won't make you all say goodbye. But awesome. Thank you. Thank you. Okay, I'm ending. But I miss you guys already. Okay.